Welcome back, Algebra 2. Today we're going to be using Desmos, which is a free online graphing calculator. It's available at desmos.com, or you can also download it as an app on your phone. Today we're going to be looking at the graphs of absolute value, so I'll show you two ways to get it, and then we're going to look at some transformations of this parent function. So y equals absolute value. To get absolute value, you can just type in ABS. Absolute value of x looks like that. That's one way to do it. Or we could also do y equals, and then if we use the little keyboard up here, there's our absolute value bars. We can put those in and we get the same thing. So you notice from this that this is absolute value. It's V-shaped. Basically, it's like two lines that are put together. If we graph y equals x, that's our linear function, but everything that was negative down here, we're not going to take the absolute value, so now it's going to be positive up here, so it gets reflected above the x-axis. So we want y equals absolute value of x, and now I'm going to type in another function. We can still take the absolute value of x, but if I put something on the inside, like y equals absolute value of x minus 2, we can see that it's going to be moving. This moves it to the right 2 spaces. If I do absolute value of x minus 4, it moves to the right 4. If I do plus 2, it moves to left 2. And plus 4 makes it move to left 4. So let's go back to y equals absolute value of x minus 2. And then if I add or subtract on the outside, we can see what happens. And again, we want to compare this transformation with the original. The original had its vertex at 0, 0. So the turning point or vertex here is at 0, 0. And now that extrema has moved up here to 2, 4. If I do minus 4, that's going to shift it down 4. So we can move it to the left or right if we add or subtract on the inside. We can move it up or down if we add or subtract on the outside. We can also put a negative on the outside. So if I go negative absolute value of x, then I get a reflection across the x-axis. So everything that was positive is now going to be reflected below here and becomes negative. So putting a negative on the outside will reflect it down. What do you think will happen if I put a negative on the inside? Doesn't look like anything happens, but it actually flips it around the y-axis. We just can't see it with absolute value because absolute value is symmetric across the y-axis. Now let's add something to the outside. If I put a 2 on the outside, we can see that's going to change the slopes of the line. So normally the slope of the lines are 1 and negative 1, but now the slopes would be 2 and negative 2 on this side. It makes the graph skinnier, or it stretches it vertically if I put a 2 on the outside. What do you think will happen if I put a 4 on the outside? It gets even steeper or narrower. And even a 6 gets even more steeper. So the bigger the number, the steeper it gets. If I put a fraction out in front, then it gets wider. The slopes now become 1/2 here and negative 1/2. And again, if I put a negative out in front, it's going to reflect it down. So in general, you should be able to do transformations by either adding, subtracting on the inside, makes it move to left or right. Adding or subtracting on the outside makes it move up or down. And if it's negative out in front, that's going to reflect it. And if we have a number out in front, that's going to change the steepness. It gives us a vertical stretch or a shrink. That's it for now with Desmos and transformations of the parent function. Hope you enjoyed. Bye.